Welcome, Acellus Explorers. Today's topic is going to blow your mind. Today's topic are volcanoes. Volcanoes are awesome and scary at the same time. Today we're going to explore volcanoes. We're going to talk about what one is, where do you find them, what are the parts of a volcano, and what can we get from a volcano? Isn't that cool? At the end, we might just erupt our own volcano right here in the lab. Let's begin. What is a volcano? Well, a volcano is a mountain. A mountain that is a breach or a break in the crust of our earth. A volcano in that mountain usually will have a chamber or several chambers. These chambers underneath the volcano hold a substance called magma. This substance called magma is liquid molten rock. Let me explain what that is. At the center of our earth, it's very, very, very hot. Think of it like hotter than an oven. The rock that is underneath our crust is actually so hot that it is melted, and it creates magma. Now, you may have seen what you thought was magma outside of a volcano, but I have something to teach you. When that magma can seep up from that chamber, up through that mountain, to come out the top or sometimes on the sides, it actually changes to lava. It's just a different word that we call it. That means it's been exposed to air. As soon as that volcano has erupted, or lava is now creeping out of that mountain, that lava will start to cool. That cooling lava, guess what? As it cools, it turns right back to stone. The type of stone that typically comes from this type of lava cooling is something called obsidian. Say that word. Obsidian. It's a gorgeous black rock. Now, this gorgeous black rock, if you hold it up to the light, looks like black glass. Isn't that cool? That means that it got super hot, super quick, and it also cooled quickly. Now, boys and girls, I bet you're wondering if you can see a real eruption. Are you ready? Sit up. Here we go. Wow! That was amazing! Did you see that lava coming? Did you see that mountain? And the lava so abruptly being pushed out of that mountain? What else did you see? Maybe not the mountain and the lava, but what else did you notice? Think about it. You know what I saw? I saw clouds of dust. Well, we don't call it dust, we call it ash. I also know that what caused that amazing eruption was a buildup of pressure and gas and release of gases. When you have an active volcano, it can be a beautiful sight, but extraordinarily dangerous. Now, where do we find volcanoes? Well, usually where mountain ranges are. That's right. And we talk about many of the volcanoes are underwater. More than half of the volcanoes on our earth are actually underwater. But one of the volcanoes that is in the United States that is active, right now she's dormant, that means she's sleeping, but was active in 1980. Now that may seem like a long, long time ago, but I was even born then. In 1980, I was 8 years old. And a very special aunt of ours lived near Mount St. Helens. There's a picture. Did you notice that beautiful mountain? Now I want you to see the mountain after it erupted. Wow. Do you see that top missing? That's what happened in 1980. It erupted. Now my very special aunt knows that we love science in our family, and she lived near Mount St. Helens. Guess what's inside? Remember I told you about the ash that comes from the volcano? Boys and girls, this is the ash that she gathered from her front yard, from Mount St. Helens, the exact mountain you just saw. Now, when I touch it, it just feels like ash. I mean, it feels like super, super light dust, almost like confectioner sugar. Okay? Now, I want you to listen carefully. Remember how I told you about the rocks that can be formed because of a volcano? A very special rock that came from the erupting of Mount St. Helens. Geologists went after the eruption and everything cooled down and everything was stable and much of the ash washed away. Those geologists went to Mount St. Helens, started looking in the mountain and opening pieces and parts. They found a new mineral. They found a new rock. That rock is called Helenite. Remember I called it Mount St. Helens? It's Helenite. And guess what? This ring that I'm wearing is made of Helenite. What color is it? Green. So as Mount St. Helens and what that mountain was made of was exposed to huge amounts of heat, and that obsidian began to cool, this exact gem, this beautiful green mineral called Helenite, was created. Now what's really cool is that humans and scientists are amazing. So what they did, they figured out a way that even in a lab setting, just like the lab setting we have here, they took parts of what is Mount St. Helens, they could heat up the rock. And after they could heat up that rock once again, they could create their own Helenite. That is awesome. Boys and girls, I'm going to be honest with you. I cannot wait to show you what an underwater eruption could look like. Are you ready? What are we going to look for? We're going to look for magma escaping, okay? Magma escaping out of the mountain, and there's going to be a plume, or it's going to begin to flow. Now, in water, it's going to look a little different than it does in air. Are you ready? Let's do it. Explorers, we now get the opportunity to create an underwater volcano with this lab. Now, let's recap what's going on. We just spoke about how 70%, that means more than half of the volcanoes that are on our Earth, that occur here on Earth, happen underwater. The Hawaiian Islands, a beautiful place to go visit, were all created because of underwater volcanoes. Once again, underwater mountain, magma leaves that mountain, that lava is going to come from that underwater volcano and create new rock. And as that grows, all of a sudden we're going to get islands above sea level. Let's go ahead and create that right here, right now. First things first, any time that we're in the lab, two things have to happen. I'm using a heating element and I have long hair. Any long hair in a lab, look what I'm doing. I have to tie it back. That is the rule when it comes to lab etiquette. Take a look. What am I not forgetting? Those goggles. You must wear goggles when you're dealing with any heating element. And oftentimes, I'll even use gloves. I'm all ready to go. I'm going to take here, kids, all this is 2 clumps of red wax. Now, I'm going to put this on top of the heating element. This heating element is going to heat up to 400 degrees. As that's also doing a melting job, I'm going to put just a little bit of sand here. I'm not going to fill it halfway full, maybe a third full. This is going to represent the Earth's crust. Remember, magma is underneath the Earth's crust. Here we have our magma. Woo! Oopa! Our magma is underneath that. Look at that, awesome. That magma in our demonstration is tucked underneath our crust. And now I placed water. This is not salt water, but of course, in real world, that would be salt water on top of our crust. Now here we go. What are we seeing? Are we seeing some gas bubbles being released? Now we know that's part of a volcanic eruption. Oh! Take a look at that. As I turn it, take a look. We have magma leaving the Earth's crust. It is look at that. And as soon as it's cooling down, it's creating the hardened version of that wax. So much like that magma when it leaves turns into lava, and that lava turns into obsidian. What an amazing, amazing example. I see gases being released. I do not see ash. Wonderful. I'm going to turn this heat down and turn it off. Oh, we had another eruption. What? Now that's awesome. Boys and girls, when it comes to volcanoes, whether they're above sea level or below sea level, we see some consistencies. We see gas releasing. We see a liquid. It's going to be a molten lava, okay, magma that's leaving the volcano, the mountain, we call lava. And then we see as it cools, it hardens to create that new rock, that new stone, the Hawaiian Islands. Man, volcanoes rock. Until next time.